All right. So, good morning, good evening, or good afternoon, wherever you are. Hopefully everyone can hear me appropriately. I am going to get started here in a few moments. Just going to make sure everything is operating properly. We do have some private attendees who are joining us over either phone or some Connect session. And if you're one of those, I'm just going to ask you to mute your mics unless you actually need to use it. So give it a minute or two here. Just going to make sure that all the live streaming indicators are go, and I'm going to get started. All right. If you are experiencing issues, whichever way you have to talk to us, give it a try. We'll do our best. So we should be able to type some stuff in the YouTube chat if you have any questions there or comments. And if you are joining us through one of the private channels via Adobe Connect or elsewhere, feel free to voice your questions or comments or whatever else that you want to communicate. And generally speaking, wherever I get information or feedback, I will send it back out via the live stream so that everybody has a record of it. Generally speaking, making sure that everybody's on the same footing here. Okay, so since it appears that nobody is joining my audio conference, which I'm going to drop off of that. If you are one of the participants whom I've invited, just let me know by chat on Connect if you want me to join back. Generally speaking, I'll wait. I'll give people a heads up to join before, and since nobody's joined at this point, I'm just going to go ahead and disconnect from that. So I can still hear you off of Adobe Connect if you have any voice comments or questions or anything of that sort. Okay, so what I'm going to do today is I'm going to go through what is publicly available regarding Android Automotive, and I want to highlight that right out of the door here because there is, obviously this is an ongoing effort on Google's part. There is still going to be things that are likely to be announced, things that are still in the works, and so on. So what you see here is just what's in the Android open source project. You may obviously have seen, or if you are one of the partners who are working on this, have access to additional material or additional information. But overall, what I want to address here is just the things that are you can find out just by perusing either the sources or Google's websites. Okay, so without further ado, and by the way, the slides will be up there after the presentation. They will be on the usual terms that I use, which is CC by SA. So have fun with that. If you're not familiar with my work, I wrote the embedded Linux book for O'Reilly in the early 2000s, the embedded Android book in the early 2010s. And if you go looking in the kernel sources, you'll find my name at least in one file. And until somebody discovers that it's no longer of any use, and obviously it'll see its end of days at that point. In any case, I've been involved in open source for a fairly long time. I'm widely known for having contributed the Linux Trace Toolkit, which was one of the first tracing tools, if not the first tracing tool for the Linux kernel. And have been enjoying effectively helping people take open source software and putting it in all sorts of weird devices, including cars, over the years. Now, despite my background, as I usually tell people as a disclaimer, I don't actually claim to know everything. I don't. I wish I did. So you may have questions for which I have absolutely no answer, and you may actually know more about some of the topics that I'm about to discuss than myself, and in that case, either please feel free to share. Additionally, I'm, an eager learner, and if there's anything that I say here that just sounds too crazy for you, then by all means, please do say so on the on the public chat on YouTube or elsewhere, and we'll correct the course as it needs to be if that has to happen. Why would you want to use Android in cars? I think that's kind of like the first question to be asked. And by the way, some people have commented to me ahead of this presentation that how the heck are you going to fit all this material in whatever session that you've got on YouTube? And so, generally speaking, I time those things to span about an hour and a half. And generally, if you look at my other presentations on YouTube, they've lasted about that long, about 90 minutes. So obviously, this is not going to be the same sort of coverage that I would give you if this was a class setting in a curriculum where we were doing hands-on or anything like that. But in the case of this particular session, my goal, and I guess this is one of the first questions I want to answer before I even head into this question, my goal here is to provide you sufficient level of information that you know where to start looking for things, and that you understand, generally speaking, the architecture of what you're dealing with and how the parts kind of fit together. If you are familiar with the Android internals already, that should be good enough to give you a good head start into exploring the additional things that have been added for car in the AOSP. Obviously, again, this doesn't cover things that may not be there. But if you want to get into the use of Android in cars and want to know what's in the AOSP, this session will actually answer many of those questions. Okay, why would I want to use Android in cars? Users have gotten accustomed to the pinchy, zoomy, swipey kind of experience on their phones, and they increasingly expect this on many other devices. Be it cars, but be it also kiosks, be it medical devices if they have to operate one, anything else. This starting to get kind of like the experience that people are expecting from their devices. So that's, I guess, a primary motivator. But Android in and of itself isn't the only operating system that can pull this off. Other operating systems can probably also do the same thing. And sometimes I do get the pushback, say, well, I could do this with X or Y, Z. And yeah, sure. But then you go down the list there, and the other thing that users are increasingly also expecting is an app and developer ecosystem, right? So they expect to be able to have apps that they can install for whatever service, social network, what have you, that they're accustomed to using. And yes, some of these are questionable in a car kind of environment. Do I actually want my friends pushing me videos that play on my head unit or whatever else? That's questionable. But still, this experience of, okay, I want to add this additional functionality, go ahead and install it, is something that customers or users are increasingly, minded to actually be able to pull off. And the one thing that you really can't beat Android as is really the developer ecosystem. So there are, a large number of developers out there that are familiar with the Android ecosystem and developer APIs, and that can pump out applications for this platform. If you go ahead and you use something else, it's not that you won't find people that can't actually code for your API. There are very talented people that know how to code for other operating systems for sure. But it remains that there's a huge application developer ecosystem around Android, and that is very difficult to beat. That really is hard to replicate, and people have tried, right? And some people have just abandoned that idea and just embraced Android and went with it. Obviously, the other thing is that we're increasingly expecting our devices to be connected permanently in one way, shape, or form. Moving forward, other things like audio assistance and real-time data about what's happening in our world, that too is something that is increasingly expected from users. So for all these reasons, I think that Android is a good candidate for these things because it's already doing it well on the handsets, and it is open source, right? So it's available to you to download, do whatever you want with it. And we can talk about challenges a bit, and you'll see here down there that I've got, additional challenges. I've put, Android is controlled by Google. That is certainly something that is always in the forefront of the folks that we've talked to that are trying to or have started putting Android in cars. Is okay, what if Google pulls the plug? What if Google does this? What if Google does that? Since it's open source, at some point in time, you can always say, okay, well, that proprietary thing that you're giving us is no longer working, or you're not giving it to us in some acceptable terms, hence we'll stop using it, we'll go with something else. So that's always a possibility, and I think that's always somewhere in the back of the mind of any decision maker who's looking at using Android. Now there are challenges irrespective of this, right? That present itself when you look at trying to integrate an operating system such as Android in an automotive use case scenario. Sorry, typo there. So integration into existing car environment. So how do you integrate Android into a car because it's mainly geared for phones, and yes, over the years have Google has added support for other devices, but this is where kind of like it's its natural environment. So starting from this, going to car, there's kind of like huge gap. And how do you actually make this happen? So one of the things that we'll see here is the various things that have been added to the AOSP to make that possible. Another concern, obviously, is security, and that actually has technical ramifications, but also possibly some political or long-term ramifications that aren't necessarily just technical. Some of these are going to be business issues. So security for this is one thing, and if this stops being updated in 2-3 years in terms of software updates, it's not that bad, because at the end of the day, I'm probably going to be changing this in 3-4 years, or whatever. At some point, I'm going to get bored of this, and some new feature is going to come out that's going to make it such that I won't update, or just my contract just renews and they give me a free phone, so I will actually probably replace it. I'm unlikely to replace my car that rapidly, or at least that's not kind of like, at least for now, the way people think about cars. There are various changes in the industry. Where people thinking of pools of cars and that sort of stuff. We'll see where it goes. But generally speaking, the current pattern is person buys car, expects it to last for a long time. How do you conduct security updates for operating systems that have been out there for 10-15 years? That's a bit of a challenge. Especially as the root of this software, since it's open source, eventually stops being updated. What do you do with kernels that are 15 years old? Challenging, all right? So it's not something specific to Android, but it is something specific to trying to take an operating system such as Android and bring it in the automotive use case scenario. Upgradability, how do you continue upgrading something if at some point the future versions of this operating system start demanding more and more resources of the device, and then the device that you issued 10-15 years ago, or whatever, 7-8 years ago, no longer can actually technically on the hardware side be updatable. What about power consumption? The car industry is very sensitive about those things. I've had numerous conversations with people in the car industry where they said, there's no way that we want something eating up our battery all the time. And this is kind of like a sort of a non-negotiable mindset. So how do you deal with that when Android doesn't presently, at least in as far as I know, provide us with any sort of hibernation capability? The rear view camera, right? This is something that has to come up quite rapidly when you put the car on, and Android, generally speaking, in terms of booting quickly, can have some issues because there's a lot of things that happen at boot time. Also, storage rear leveling. So if we're writing off into the storage device, how long will this last? If we start doing mobile phone style writes onto a storage device that's supposed to last us 10 years or 12 or 15 years. How's that going to work out? So those are kind of like just basic technical, challenges. Some of them more, that require a bit of business forethought, or at least some sort of analysis as to, okay, we're thinking about bringing this operating system here into our cars. It has some software challenges, but it also has some business challenges. How do we face those things? So obviously, the other items I mentioned, which is this is controlled by Google. Again, what I said earlier applies. and the fact that it's geared toward replaceable devices. So this is also something I touched on. So generally speaking, my current thoughts on Android Automotive are the following, and this is again based on what's available out there. Google may be working on some amazing stuff that they've shared with their partners that we don't know about, but for now, this is what I can see from looking at the AOSP. So it seems that for now, the final architecture approach with regards to certain things in the AOSP is TBD. I mean, some of the things, and I'll point those out as I go, some of the architecture choices that they've made seem to point to the fact that they're not exactly sure where things will land. And sometimes they actually quite deliberately say so in their documentation. They say, we're not exactly sure how this is going to be done in the end. Presently, we're doing it this way. We'll see later on how it actually works out. This is something I mentioned earlier, so there's a lot of stuff happening which is not public. Obviously, it is in flux. There are some key issues to be resolved. I've already kind of touched on some of them on my previous slide, but I will get into a bit more detail later on as we talk about the specifics of the stack. General purpose app development, even according to their own documentation, is effectively in alpha. So this idea of being able to load on your head unit or your IVI some sort of application that a third party is publishing is something that a lot of people are sensitive about, and for good reason, right? This is an actual car. I'm driving this thing. I don't want it to just start, randomly interrupting my my driving with something that has absolutely nothing to do with the context of my concentration, which could actually cause some issues. All right. Okay, so let's talk a bit about what I want to cover in detail. So we're going to go into an overall introduction, just kind of like fleshing out the nomenclature that they have out there regarding the use of Android in cars. Then we'll start looking at the architecture. What are the pieces that have been added to the Android architecture? And we'll go through each one of those one by one. And then I'll start talking about some specific subsystems that are documented in either their documentation or that have some sort of information about them in the AOSP. And to assist me in all that, I've got here a Android emulator image of the car system, effectively, which I'm going to use just for, and it actually just crashed. That's awesome. Sorry about that. Let's just restart this guy. This is kind of like an easy way to get into looking at what Android Automotive gives us. So you can see here it's doing its a little boot animation, and eventually it's going to get me to the launcher screen for Automotive, and this is what you get effectively for the emulator. Okay, so if you have started looking at that, you'll see that they're using kind of like two things, and they're separate, but for me they're confusing. So when they refer to Android Auto versus Android Automotive, so the Android Auto really is an application app that's on your phone, and it projects onto a device that is Android Auto capable. So that means that the IVI is not running Android. It might be running something completely different. It could be also running Android, but whatever. If whatever it is it's running, the application on the phone can then project onto this device some app content. That is not the topic of this presentation. What I'm interested in is the actual use of Android itself in the car. So that is, it's running on my IVI or my head unit in some way, shape, or form. Okay. Now, in terms of nomenclature, it's not. I mean, at least reading one of the articles that appeared earlier this year, it's a bit confusing. I'm not exactly sure what they'll end up calling this. So there was reference here by some of the Android folks to the use of embedded or native or powered by Android. Let's see where that actually eventually ends up landing in terms of marketing terms. So what I'm interested again is what has to do with the use of Android itself on the unit, not the actual projection mode that you've got available in there. So the interesting thing is that the additions for the car are an extension to what is already there in the AOSP architecture. So if you've seen some of my other material elsewhere, like the embedded Android courseware that I've got out there, I mentioned there are different flavors. of Android that are available, and that in most cases the underlying architecture is the same, except there are some additions that are specific to use cases. And this readily applies to the automotive use case, where you've got some bits of pieces that are added throughout the stack to actually make the Android operating system fit for use in cars. Some of the internals documentation that you see on source.android.com is somewhat out of sync, out of date, or incomplete. So your mileage will vary if you just go with the sources. There is a lot of app developer documentation, but from my perspective, looking at it from the internals part, it's a bit of overkill. I mean, there's a lot of stuff, but then if you look at what you can do with it, it's a very, very tiny use case. I don't know of any reference hardware that's for automotive. If you do know of such a thing, I'm happy to learn about it. But what I've been using personally to explore this is the emulator target, which I just showed you. So if you just do lunch, you can go see that there's some car targets. The one I'm using right now is AOSP car x86-64, and I'm actually running it as -eng, not user debug, not much of a difference. And then you can effectively shell to it and go take a look at what's around. Now, I'm doing this on 9 just because that was what was available as I was preparing this presentation. But 10 just came out actually yesterday, and the sources have started trickling out. So I do have a successful sync of 10.00R2 this morning. I'll try to use that for part of the explanation if I can, but you may find that my slides may not be in sync with what's in the actual sources of 10, because a few things have changed. So I might just fall back onto 9.x, because I know that actually works. And of course, I didn't get the chance to actually build 10 and give it a run and try to run the car emulator in there, but that might be something that I'll attempt shortly. Okay, the architecture of the car editions for Android. Okay, this is the general, behind the blue boxes here is the general diagram I've been carrying over the years regarding Android's architecture, and it hasn't changed much. For those of you who aren't familiar with this, let me just give you a really quick rundown in this. So you've got the Linux kernel at the bottom, which gives us everything that Linux gives to other Linux distributions, except it's got a few bells and whistles to allow this stack here to run on top of it. And the color coding here in my slide is gray is generally C code or native code, yellow is system service or core related, framework related Java stuff, and then you go up in the top here and the orange stuff is regular applications. So on top of Linux kernel, we got a bunch of libraries, Bionic being the main thing here with the C library. I'm not going to concentrate on that this time in my explanations, but what I want to show you here is that you've got these automotive HAL stuff. So behind this box it says hardware abstraction layer. So the hardware abstraction layer part for automotive is called automotive, and I'll show that to you later when I go through the code. You've got a bunch of native daemons, nothing here particularly to point out regarding automotive. You've got init and toy box, which is the shell. This is the virtual machine that allows us to run Java code. You've got the system services, and what's interesting for us is the car service. So there's a car service that is running actually as an independent process. You can see it actually if you type PS. And inside the car service, there are several car services. So this, unlike other system services, seems to be a multiplexer. So effectively, you call the car service to get a handle on the service, the specific car service that you want to talk to. And I'll show that to you a bit later in more detail. It's an interesting architectural choice that they've made there. I guess it stems from the idea that since it's a work in progress, we don't know what it's going to look like at the end, then maybe let's just say that we want to have some, scaffolding that allows us to get into a car service or get a handle on a car service, but since we don't know the definitive list of the car services, let's just make this TBD, and we make a very simple interface that does a getter on the service that's behind it. So I'll show that to you what this looks like in detail, but just remember that here, unlike the other system services, which you look at the car, like a power manager or package manager or activity manager, which has kind of like an interface, and then you call straight into that interface. In this case, you call the service to get the handle of the car service, specific car service you're looking for, and then you call the interface of that thing to get the services that it provides. There's a few libraries on top to give access to the service, and then you've got some built-in applications inside the AOSP that are, presumably example applications for you to look at how you can do a car launcher, how you can do an HVAC, radio, maps, or whatever else that you've got. And in terms of applications that would come from the store, presently it seems that the only sort of application that you could publish to the store for automotive is media applications. That's, at least according to the documentation that I rechecked this morning, seems to be what's available for you. If you want to look at where things are in the sources, in the actual AOSP, so if you look at the HAL stuff, it's under Hardware Interfaces Automotive. If you want to look at the service itself, it's under Packages, Services, Car Service, and then the libraries are also in the same kind of subdirectory. The apps themselves are in Packages, Apps, Car. So that's where you'll find most of the pieces of that are user-facing in terms of car application. So as I was just saying, the car service is effectively a multiplexing service. So you've all got a very basic AIDL here that gives you a get car service, which is the main thing that you're trying to call here. And let me go show you here the packages that the interface here that you're going to be talking to. So let me go grab my Android sources here. So this is 9, and we'll rapidly go check out on 10, see if it does the same thing here. So if I go under Packages, Services, Car, and then we're going under Service, SRC, COM, Android Car, and I'm going to have a iCar impl here, and so that's the actual car implementation, and you'll see that you've got all these services which are actually being declared. So I've got a car power management service, car package manager service, car input service, driving state service, and you name it. And there's a whole bunch of these, and all of these again are fetched by using the official iCar AIDL, and then you go and get a handle on that item underneath this. And if I go checking here on, say, 10.x, just kind of like giving us a sneak peek of what's being done here. So let me go in my sources here for 10. Let's just do this. And if I, by the way, this is my first look at 10, so there's some stuff here that I'm going to be discovering as I'm talking to you. But overall, the first look this morning seems to be that, at least at the top level, things are pretty identical. And if I go under Services, I still got the car here. And if I go under Service itself, going on SRC, COM, Android Car, I should still have a iCar impl, which has about, just at a glance here, it seems to have 10 kilobytes more than the last time. And then you've got, possibly additional services, which I haven't compared at this point. So you might actually want to take a look at that. Right. So this is my car system service, and if you want to see it on the device, you can it's actually packaged as an app. So if I do ADB shell here, and I do a PS, and let's go looking for just car, and you've got here the COM, Android Car right here, and so that would be effectively the package that is encompassing that service. And you can actually go check sorry, not this, but rather here. If I go out to the Android manifest here, this happens to be my package Android car, and you'll see down there that the application is marked as persistent. So this is going to get started as soon as the system boots. So it is packaged as a system service, which is independent of the existing system services, which are under the aegis of System Server Java and so on and so forth. So this is an independent app that registers a system service, and that system service then exposes its services, which are these 3 AIDL calls, onto the rest of the system. And if you do a service list, and again look for car, you're going to find that we've got car service here, and you can just go ahead and do something like a dump sys car service, and you get yourself effectively a dump of the information of those various services underneath there. So if I scroll all the way to the top of that, you'll see that it's got these star kind of like things. So package managed service, which has these things. Then you go on to another one, the input service, what it sees, and so on and so forth. And by the way, I just noticed actually earlier that you can actually do a car service -H, dumps car service H, and it's got a command line here to kind of like talk to some of the internals of it and toggle a few fields here and there. So that's a quick look here at the car service. Again, the first level AIDL is just a getter, and then the actual AIDLs are underneath that. So if you want to see what's specific about the car package manager or audio or whatever else, then you have to take a look at those things. And this is a snapshot I grabbed from last time I looked at the sources, which is again 9.x based. Only a handful of these are actually publicly available. In other words, a lot of these things are hidden away from app developers. The API is not necessarily available to general purpose use, but more inside the AOSP. So regarding the car APIs, so those that are available to or documented to application developers for use by Play, they're really just for media apps, and it says so quite literally on the documentation. And you can look at the Google Play services themselves. As Google Play services under Automotive OS is still in alpha stage. That is accurate. That is still current as of this morning. Okay. Now the AOSP APIs that are available to apps that are built within the AOSP are, from my perspective, a lot more interesting. And so if you want to take a look at that stuff, there's the support library and the carlib, which have those things inside of them. So that will be effectively on your in your AOSP under, let me go back here, under package services car. So you've got here the carlib and cart support lib. Those are the ones that you want to take a look at for what's available for use in terms of APIs in the AOSP for applications that are effectively built against inside the AOSP. Now, those are similar in package nature as what you'd find on framework-based core, but they are specific to the use of effectively talking to. If you go back to my diagram here, we're talking about having libraries that allow me to talk to the actual system services which are housed in that separate car service. Okay, so the car apps themselves. Now that is a bit interesting, and let me take you through some of this here. So just kind of like give you a quick demo of what you got in there on the emulator. So you've got a few applications. Some of them are just placeholders. So if you click on the actual navigation thing, it says, okay, no maps application is installed. Please contact your car manufacturer. And in fact, this placeholder is found as is if I go under packages apps. If I go here under packages apps and I look under car, I'm going to find what is it again? This guy is, okay, I lost track of this one. I thought it was here. Or is it in the services? I'm not, or I think it's in the services. I got confused. So let me check here under packages, services, car maps placeholder. That's it. So your placeholder here, in fact, if you go to the layout, I think it has even here the actual same string. So there, this is the actual string here, which says no maps application is installed. So this is just kind of like a stopgap thing. Okay, if you go for the media, so what do you want? You want the radio. So here's the radio application, and effectively this allows you to, the radio application. Going back here. Medium, and effectively the radio app itself is under the packages apps this time. So this one is packages apps, car, radio, and then you'd have an example radio. You've got a dialer, right? And effectively same thing here. That one is, I believe, as well underneath here under dialer. Okay, so just basic dialer application. And you've got a few additional things here like the settings and so on. They also have a specific input keyboard. So if you go here under, let me try to see here, if I go for search and I start typing, yeah, so this input method here, the keyboard that you see here, which is effectively a specific input method for cars, is also available as an app here into Latin IME. Now, the one that's kind of interesting here is the HVAC application. So if you click here on the right-hand side of here, where it looks like this wavy, kind of like the windy thing, this gives us the HVAC user interface, and obviously, you can increase, decrease temperature, and so on. But the interesting thing here is if I start kind of clicking on other stuff, the HVAC application, quote unquote, remains on the top. And HVAC here, in order to pull this off, does something special that I've seen used a handful of times in Android, which effectively allows me to overlay some display. So if you've got something that has to, say, overlay the display in a fashion such as this, where you want to monopolize the what the user is actually seeing and not allow anything else to run, then what you can do is what the HVAC application does here. And if you open the manifest, by the way, this doesn't actually have an activity. It only has a service. And if you look at how the UI is implemented, so if I go under src-com Android HVAC, and if I open the UI service here, you'll see what it does is actually it talks straight to the window manager. So it's going to go actually set up some parameters. These ones are actually test parameters. You can see here there does not exist a way to get the current state of the system UI visibility from inside the service. Thus, we place something that's full screen and check if its final measurements as a hack to get that information. And the actual display actually happens in this function or method called layout HVAC UI. Which is underneath here. It's going to say not focusable, but it's going to say type display overlay. And this is going to make sure that it's on the top there. And therefore, whenever you bring that to the foreground, it should actually be able to be the first thing on the top. And you can see here that in this case, we're add view to window manager and track. So they're just going to add this thing and effectively start receiving whatever input is done on that interface. So in other words, if I want to get something that overtakes the display in this fashion, and again, if I click on other stuff, it's still happening in the background, but the HVAC is still on top, and if I can remove it, it goes back to my other application. So that's generally kind of like the what you've got. And I kind of skipped the launcher, but there is a car launcher, obviously, and the launcher here is under just plain launcher. And much like any other launcher, if I open the Android manifest, it's going to have here an activity which is going to respond to intent, action main, category home, default, and that kind of stuff. So if you got something like that, it'll usually respond as being the home or kind of like default launcher for that device. So that's for effectively the applications, and probably if I go here in 10.x, they might have some more. So if I go here under packages, apps, car, they do seem to have this, let me see, just kind of quickly comparing here visually those two things. Oh, sorry, I was here going up to apps, car. So you've got cluster, which has been added. You've got lens picker still there. If your local media player is there. Media messenger, okay, that too is there. Notification overview. Notification is new. Settings, stream, system updater. Yeah, so there's just fairly good similarity here. Link viewer is new as well. So, I'll definitely explore this in more detail a bit later on. So that gives me effectively the user interface that is going to come on top of the system service. Now, in order for all of that to actually operate, let me go back here to my architecture diagram. So we've looked at that. I've told you that you've got pretty much in terms of public APIs, the only thing you've got here is media. And I've kind of looked at how this works. Now let's take a look underneath the hood, effectively in the automotive HIDL or effectively hardware interfaces that are provided to us. So if you look at the HIDL, there's effectively 3 HIDLs which are exposed: audio control, EVS, and the actual vehicle itself. So if I go out here all the way up to the top, oops, sorry, let's just grab this, going under hardware, interfaces, and then automotive. I've got here 3 sort of interfaces that are exposed. And if you go here in 10, it's effectively the same thing when I was looking at it this morning. So, sorry, hardware, interfaces, automotive. We've got still audio control, EVS, and vehicle. And if you look at the what's inside, the APIs haven't changed. So audio control is still 1.0, EVS is 1.0, and vehicle is 2.0. And that is the same thing here in 9. We're still at those numbers. So the HAL, at least what's publicly available from what we can see, the HIDL interfaces haven't actually changed. So let's go take a look at primarily the vehicle HAL. So what do we have here? What does the vehicle HAL actually give us? And really, this is a kind of like a property monitoring sort of API. So get all prop configs, provide a callback. You got a setter here, you got a getter, you got a setter, you got a subscribe, you got an unsubscribe, and that's pretty much it. So what am I actually going to subscribe to? That's where the types HAL becomes interesting. So this is actually what's currently listed for the automotive HAL. And I would presume that, since we're the same API level in 10, that this should not have changed. And actually, the size did change, so this is a bit interesting. They kept the same version number, but they actually seem to have increased the content of it. Let's just go back and check what they've got here. The HALs not yet. Okay. That's pretty much what you want to read is the HALs are not yet frozen. So I'm presuming effectively that even though the numbers are the same, that would explain why they've changed them. So okay. So if I go here and I look at the content of the types HAL, so you'll see stuff as vehicle areas. Okay. So window, mirror, seat, door, wheel, and then you go down, you'll see stuff like the actual properties. So info VIN, info make, model, fuel, engine, engine oil level, temperature, I think they have a sort of fuel remaining, later on, and that sort of stuff. So there's quite a few properties here that you can start poking or setting or monitor for changes. There's just kind of generally speaking here. Let's see. I'm just being curious. So if I grab my shell and let's make this a bit bigger, and I did an AOSP car x86 64. And it's just keeping this the same. Let's go under hardware, interfaces, car, and let's go, automotive, sorry. And under automotive, I went for vehicle. So if I go to 2.0 and I do let's just see how big this thing is, types.hal. So we got about 3,000 lines here for the types HAL under 9, and if I go do the same thing here under hardware, interfaces, automotive, we are looking for vehicle, and let's go checking the size of the types HAL here. Sorry, I'm going for 2.0. Word count-L, types HAL. So we've got about a few 300 lines more that have been added here, and one of the things I could possibly just do for my own entertainment here is do a diff between this with the original, and let's go take a look at the one from 10 just for fun. So we're looking at Android AOSP 10.0 and then interfaces. hardware interfaces. Automotive, vehicle, 2.0, types HAL. And so we've got a few additional properties that have been added, some bunch of comments, a few more properties being added. Oh, these are seems to be quantities and pressures. Okay, yeah, they changed those. Yeah, okay, not too big, but still. You know, the key thing to remember here from the README is they haven't frozen this API yet. So in other words, they will continue to evolve this, and if nothing, I mean, this goes back to what I was saying. It is a work in progress. So it is likely that you know, this will continue evolving until they are satisfied enough that this is going to be a general purpose solution for, you know, most units out there. So that's for the actual HAL definition itself for the vehicle, and they've got additional interfaces here under, say, EVS. This is the external view system. So you got the enumerator and the display actually in the camera. And I'll explain to you how this works later on. This is the design they currently have, which is effectively you've got an application that grabs frames from the camera, sends them to the display. And that essentially what this application ought to be doing is just take the frames and send them on the side and get them to the actual display. They've got an audio controller here, and the audio controller actually is layered on top of Android's existing audio control mechanisms. So this is not a new audio stack, it's just layered on top of the existing stack. And there is a default implementation for some of the stuff. So if I go here under vehicle 2.0 default, you're going to find here a default implementation of the vehicle HAL properties. And what do I mean by that? Well, if you go here on the device itself, so if I do an LSHAL, and let's go looking for vehicle, right? So we got a vehicle HAL here, which is actually being used. I believe that we also have the corresponding process because it is running as actually a service. Sorry. So yeah, you got an Android automotive vehicle service HAL, which is running over Binder. So if you're not familiar with that, have a look at the treble presentation that I gave a while ago, which also is available on YouTube. So effectively, this is a binderized HIDL implementation, which is actually going to implement that API, which I just mentioned is publicly available. So that is for the HIDLs. Okay. Now, talking about the exterior view system. So this is interesting because they tell you quite explicitly they don't want you to depend on the surface flanger, because the surface flanger is going to come in way too late in the actual boot process. If you want to be displaying within 2 seconds what's going on in your rear view mirror, for example, rear view camera, then you have got to use something else. And that's where they propose this sort of architecture. And this is straight from their documentation. Seems, again, current as of still today. So effectively, you've got display driver, camera driver, and then you've got the hardware side, which is effectively, you know, the camera implementation, display implementation, and on top of those, you've got the different HALs. You've got an enumerator, which figures out, you know, what you've got underneath here in terms of cameras and displays. And then you've got the manager, whose job is to actually share these cameras among, you know, applications. So effectively, one camera could be probably shared by more than one application. You'll notice that that manager itself has the same API, the same HALs right on top of it. This is just to make sure that effectively the applications will see no difference if they're talking straight to the camera or if they're talking to the actual manager. But generally speaking, the idea is the application grabs frames from the camera, sends them to the display. You know, I'm not sure that this is going to be the final thing that is going to be used. This is one area that I'm iffy about the architecture being chosen. I'm not exactly sure I like this architecture. Maybe there's, you know, plenty of wisdom inside of it that I'm just, you know, is evading me. But there's something here that I don't like especially say going straight up to the Android side of things. I personally, I'd be more comfortable doing it a bit more, level, maybe even at at an actual driver, level itself. But that's, I don't know. This is one part where question mark, still TBD from my perspective as to what the final solution is going to be on that. Maybe this is it, and we go with that. So there is actually a reference implementation of an application and manager. So if you go out to your sources under the packages services directory that I was in earlier. So if I go under packages services car, you've got here the EVS directory, which has got manager and application and sample driver. So if you want to take a look at how they propose doing it, then you can take a look at that. And again, so as I was saying, one stream, multiple consumers. That's the whole idea here. I could have one camera and multiple actual consumers of the stream. And if you want to look at the actual HIDL that they've got for this, you go up here under hardware interfaces, automotive. I go for EVS 1.0, and then you've got the actual camera, what they expect from the camera, what they expect to get from the camera, what they expect to get from the display, and so on and so forth. Okay. So their suggestion, according to what they have in the documentation, is to augment the kernel drivers to support EVS. I'm of the mind of, why don't just, if I'm going to augment the driver, why don't just kind of like pipe the output from one driver to the next driver or something of that kind. I'm not sure. We'll see what happens with this. And then I have kind of like a state diagram of how this kind of like, this should actually behave. So get camera list, ask vehicle have for notification, start message loop, see if in reverse. In that case, start the image stream and so on. And this would be kind of like what happens on the actual application. So get the buffer, copy image, and then draw overlay graphic if you have to, and then send the graphic out to the target buffer where you're going to display it, and go from there. So it's kind of pretty straightforward. Okay, so the properties which I showed you before, get sub, subscribe, and if you want to see the list of things in there, then you go in that HIDL interface, and they do have a few diagrams there to show you how they expect this to actually flow. This actually seems to originate from 8.x because some of these parts are not there. So, HVAC application effectively wants to power on the HVAC, talks to the car service, which turns the HVAC power on through the vehicle network service. Not there. Okay, you can't find that. HVAC power on, so it goes to the VHAL, which goes to the actual HVAC ECU, the electronic control unit of the ECU, of the HVAC, sorry. And then turns it on, and then whatever else has to happen there. Same thing for setting temperature. So set the temperature to this. Yes, the temperature has been set, and so on and so forth. Okay, so this is the property, setting and getting stuff, and possibly subscribing to notifications from that sort of thing. Okay, so Android is responsible for some of the audio, but not all of the audio. So it's responsible for things that you would expect of Android, but it's not responsible for anything that's mission critical. So if it's like, you forgot to put your seatbelt on, or you're about to hit the car in front of you, not Android's business sort of thing. So there's supposed to be some form of hardware mixer underneath Android that deals with those mission critical audio cues that might be happening, and this diagram they have there kind of like shows it to you. So there's expected to be an external audio mixer that gives you all the external audio signals plus what Android is going to give you, and then this goes off to the car amplifier or whatever audio output that you might have to go out to the driver or passengers. So you've got obviously the Android side of things, so you've got a player going in audio flinger, which is going to take multiple streams, sending them to mixers, and then effectively to logical buses, which are now no longer identified as being specifically coming from one audio source or another. So they have a few sequence diagrams of how audio playback is to be made, and I kind of like them because they seem to be kind of at least kind of give you a mindset of how they expect you to make this happen, and I think that architecture makes sense to me. compared to some of the other stuff I've seen. So for example, if I want to play something on the radio, I press power, I say go to this station, so the radio application tells the radio service it wants to do this, so effectively the tuner starts tuning into that to the channel. Then we ask for focus from the audio manager. It is granted. Then we go to the audio flinger, tell the mixer to actually place a sort of splice between those two things here. Can't remember what the name of the actual specific name, patch I think they call it, or something. So effectively they're going to patch the output from this straight out to the mixer without it going actually through the Android HAL. So we're not going to take the audio back up to bring it back down. We just tell the hardware send your audio out to the mixer. If I'm doing this, playing the radio, and then navigation event happens, what am I going to do now? So kind of like same numbering as before. They're still keeping the same numbers, but they're kind of adding more numbers. In this case, the navigation application is going to request a temporary focus, transient focus, or grab transient, something like. By the way, the arrows here are inverted, 7 and 8. Whoever maintains this diagram at Google, I think your 7 and 8 are inverted. Anyway, so navigation application is going to request focus. It's going to get the temporary focus. It's going to go out here, play something off to the mixer to say, okay, turn right, turn left. Once it's done that, it relinquishes the focus. Focus goes back to radio, and radio continues playing whatever it was doing. If we are playing an audiobook, it's slightly a bit different. Because now there has to be a way to actually, sorry, if you want to start playing the audiobook, sorry, I was going to get into the next diagram. If I want to start playing an audiobook, in this case, what's going to happen is audiobook player is going to request a focus, and this is going to be a permanent focus, and effectively we're going to tell the radio, hey, by the way, you're about to lose focus entirely. So radio says, okay, that's it, I'm done, stop taking my stuff. And then effectively the audio book application gets the focus. It starts playing whatever has to go out to the mixer. This one is interesting. It's kind of like the full Monty, I guess, or whatever it is. It's like the whole thing kind of brought together. I'm playing an audiobook. A navigation cue comes in. How am I going to deal with that? So if you kind of follow the numbers, and they have an explanation there in their text, what will happen effectively is that the audio play or the audiobook application will get notified that it has to pause, and then after it has it'll pause there. The navigation will play, and it will stop. I'll restart playback once the navigation instruction is done. So when the system is about to say turn right, if you were listening to an audiobook, the audiobook will pause there and unpause automatically when the turn right audio cue has been given. So again, I think the architecture they have for this audio stuff seems pretty sane, and as far as I can see for now. Okay, power management. So in the case of the power management, so Android is running on some sort of SOC, and that board is assumed to be somehow controlled by the vehicle master controller, what they call the vehicle master controller, VMCU, or whatever is the core of your car that's actually handling, some sort of centralized control over the various components. So the idea is that the waking up and the sleeping of the Android SOC is going to be controlled by the VMCU. And so the Android automotive is meant to be kind of like cognizant of this deep sleep state where it effectively suspends to RAM. Android currently doesn't do hibernation, so it doesn't actually store something to disk, effectively being able to completely power itself off and then restore from that. Personally, I think this is one thing that's going to have to be solved at some point in the future. I don't know where, when, how. But somebody somewhere is going to have to come up with a good story about Android hibernating, because there are various use cases where you actually want Android to just, stop, suspend itself, but not actually reboot in full. I don't know who's going to address this and how, but we're going to have to figure out a solution for this at some point in the future. I think the current mindset is to try to push for the suspend to RAM as far as possible, and try to kind of like fight the classic mindset in the automotive industry that nothing should be taking power when the battery's off. But we'll see. Okay, I'd like to see this being resolved for a variety of use cases, not just the automotive one. So there is a car power manager, and there's a car power manager service, and basic kind of sort of state diagram here. The thing is off, the application processor comes on. There's a shutdown trigger sent by presumably the VMCU. It prepares itself to shut down and goes into deep sleep, and there's a toggling between display on and display off. So this is the interesting part here. So the vehicle HAL here allowing us to talk to the VMCU with the car power management service, and then the car power management service using libsuspend to actually go to the application processor and say, okay, time for you to go into deep sleep mode. All right, and this is kind of like the communication diagram that they have on their website to document the flow of things, and this seems sane as a kind of like as a flow of things. So initiate the suspend, the VHAL goes up to the car power manager service, tells it that this is going on. The car power manager API transfers this over to the application, which does whatever it has to do. Says finished, and we start actually shutting the thing down. Eventually, we say we're ready to suspend, and then we suspend the actual device. And obviously here, presumably all the applications have been told, okay, that's it. You're supposed to be asleep now. Waking up, similar sort of thing. Powering up the device. We're waking up from suspend. Effectively, the kernel is kind of like waking up as if it got a hardware interrupt. Does this thing. We can then poll the wake reason. Why did we wake up? Get boot reason, wake reason, and so on, and eventually possibly return to suspend if necessary. Okay, and then they have. I just kind of replicated this in my slide set, but they have a few diagrams up there in their documentation that tell you the class hierarchy of all this stuff. Not super kind of like intuitive unless you're actually looking at this code in a great level of detail. Which gets me to where leveling. So, all right, so this is from their own documentation. Okay, average data written to phone per day is about 10 gigabytes. We expect Android automotive implementations to have more eMMC writes than a phone. So if there is one part where I think the Android automotive story kind of hits the brick wall, this is pretty much it. There has to be some sort of forethought put into how do we deal with the fact that a user wants to run applications which look like applications they have on their phone, or maybe even the same applications, and when those applications don't care or are not made to actually take into account that they may be used for years on the storage that they have to operate on. So this is something that doesn't, for me at least, have a good answer right now. And honestly, it may not be just this is not just Google's responsibility. At the end of the day, as I started off, I said, we're trying to use this operating system, which is geared for mobile devices, onto cars. And that has some challenges. And I think that's one big one. So I'm not sure that the solution is strictly a software solution. So one of the things that they suggest here is they suggest using adaptable storage SD cards. So in that case, effectively, when you're using an SD card, you can say this is adaptable storage. So effectively, the storage is encrypted in such a fashion that if you were to remove it, it's completely useless. But as long as it's in the device, you can operate on this SD card as if it was some internal data storage for applications. But regardless, even if I go with this, let's say I roll with that, what does that really mean? Does that mean that I have to go to my dealership in 3 years, 4 years, 5 years and have the SD card changed? Or is this an operation that the user is supposed to be doing? Not entirely sure. That's unclear to me, okay? So then they have some stats there of saying, so for a 16 gigabit eMMC card with 3 kilobytes of erase cycles, lifetime versus writes, and they tell you, if you're writing 32 gigabytes a day, that's just 5 years of a lifetime. So what do I do with that? Do I show up to the dealership for service? If you look at the dump sys of car service, which I did earlier, I didn't focus too much on that. Actually, let me do it this way. Let's do ADB shell dump sys car service less. And if I scroll down a bit here, you'll see that in fact towards the end, one of the big things that they've got here is effectively a tracking of the wear of the storage device. So let me just page down a few here, and you'll see here that it's actually just printing out information about the amount of stuff that's being written onto the storage. So this is something that, again, I don't have. There's no good story here for this for now. I'm not sure that the problem is strictly Androids. There's a problem there. Somebody is commenting here that it won't meet the temperature requirements. I assume this is regarding the number of writes being done on the device there. So again, this is something that yes, there you go. So the commercial SD cards won't actually fit the temperature requirements. Thank you, sir. So this is something that has to be talked about. We'll have as an industry, we'll have to figure out an answer for this. I'm again not sure that this is strictly a problem Google has to solve. There's certainly something that Android can help in that regard, but there's another story to this that is hardware specific. Okay, boot time optimization. So minimizing the boot time of Linux, and so this is kind of just one of the things that oftentimes when we talk to car manufacturers, comes up as kind of like a hot topic. So, okay, how do we minimize the boot time of our device so that when the person puts the car on, they get to Android's launcher or whatever it is really, really quickly. If you just look at the kernel itself, all right, the trying to optimize the kernel's boot time, that's a topic that's been studied at length by a lot of people. There are a lot of conference presentations that actually talk about that, and I strongly encourage you to look around. If nothing else, the Embedded Linux Conference has had several talks that covered that. Strongly encourage you to go to elinux.org and see what kind of documentation there is to do that. So I'm being a bit drastic in my statement here, saying that little to no effort from Google to minimize Android boot times. Android boot times are unfortunately something that is still a sticking point for a lot of people. If it was possible to hibernate Android, for me, that topic would actually effectively be taken off the list of things that needs to be worked on. If we were able to hibernate, then I could boot the device, put it in some sort of known to be good state, and then every time I kind of power the thing on, it comes back from hibernation. But I'm not able to do that. So if a full boot is required, that's where it generally takes a lot of time for Android to get it to boot. There are, on that specific topic, a few scattered presentations here and there. If you bug me a lot via email or social media, I should be able to drag out some links about that. But generally speaking, that is a problem. Sorry, I'm just grabbing a comment here or a question on the YouTube chat. Give me 1 second. An Android framework which using system service can be started along. Any Android framework using which vendor system service can be started alongside with any other system server? Which system? Sure. Yes. If you've got I'm not sure if I fully understand the question or the comment, but generally speaking, if you have a custom system service, you can certainly start it parallel to whatever the framework already starts. And I guess one of the things going to that comment is that that's effectively what the car service does. It's effectively starting a system service or a pack of system services aside from what the system server is already starting. So coming back to that, so generally speaking, and you can see proof of that in the architecture of the exterior view system or the EVS. If it's time critical, try to avoid depending on Android. Try to make sure that you can get it done either in the kernel or fairly early in the boot process, independent of the Android OS framework starting up. Because if you have to depend on that, you have no idea what you're getting yourself into. It could take quote unquote forever to get to that. So last bullet point, effectively kind of reinforcing what I was saying. At some point in the future, it'll be interesting to see Android somehow address suspended flash. I don't know how, but it would be actually interesting to see that being done. So there are some build considerations in the AOSP itself. Just really quickly here, going through. If I go under packages, services, and I go to car. you'll see here there's a car product, and in here they have a few things like RC files, build files, boot animation, and so on. In this case, the boot animation zip, which is effectively taken by the boot animation application and then is run on the actual display. An overlay of what frameworks and packages has to be overlaid, and some car-specific SE policies that are required for car. So if you want to look at how does this integration fall into the integration of the car stuff in the AOSP for the build, this is the directory that you're looking at. Wouldn't Suspend Flash make wear leveling much worse? Much worse, or are we talking about a single golden image? So it could be a single golden image where effectively you boot into, you do a full boot on an OTA, and then you actually suspend to flash with that OTA, and then you continue booting with that suspend to flash image. So this would be your good to go golden image that you could use forever forward until you have to do another OTA. So from that perspective, it would effectively kind of minimize the issue of wear leveling for that sort of use case, which is the automotive use case. So it looks like the camera, there is a recommendation for not using Surface Flinger to meet 2-second requirement. Does Android provide any alternative solution to render frames other than Surface Flinger? No, it does not. So effectively, Android's display framework is Surface Flinger. If you need to do something underneath then you're talking about effectively the talking directly to the drivers or whatever you want to layer on top of the drivers directly. And effectively, if you look at the EVS documentation Google has, they recommend that you actually augment the drivers to actually satisfy your 2-second requirement. Okay, so that is for the build requirements. And one last thing, just kind of as a by the way, and this is something that we've seen in discussions with auto manufacturers over the years. Is initially even Linux was something that people didn't want to run. It's like I don't want to run Linux. I can't trust this thing. And now you're bringing all this Android thing. And it's like, oh my God, what the heck are we going to do with this? There are various hypervisor solutions, container solutions that are being looked at, used, and actually rolled out. So it's a completely different topic of its own. Have a look at that if you're interested into kind of like jail Android into some sort of controllable unit that you don't want to have directly control your hardware, whatever interface that you've got there. This may be a viable path for what you may be trying to do. And that's pretty much what I've got in terms of content here. I'm happy to take questions as they come, either on the private side or the YouTube chat, as some have posted. I'll be waiting here for a few minutes to see if some stuff comes out. As I explained, just going back to kind of like the kickstart of this presentation. We are looking at a state of the industry where both the users and the industry itself wants to see these touch-based devices available in cars. Android is a very good candidate for doing this because it's been actually successful very much in the consumer side, and plus it's open source, so no royalties involved. But there are challenges of taking such an operating system and make use of it in cars, if nothing else, because it is primarily geared, at least in terms of development cycle, onto being pushed to devices which are, quote unquote disposable, handsets or whatever. And so if you want to take that sort of operating system and bring it into such a demanding environment as the car environment, then you have to have a very solid conversations about certain topics. And I think that in some regards, Android does have the answers. In some cases, as I pointed out as I was going through, some things still I think are TBD. As I said, also, I don't think that this is the sole responsibility necessarily of Google or the Android development team. There are things in there which are kind of like industry problems that come with as a sole responsibility onto everyone when we start looking at taking an operating system such as Android and bringing it into cars. Some of these solutions will have to come from the industry itself, not necessarily just Google. So that being said, please feel free to ask any questions, and I'm happy to pick them up as they come around. Is there any limitation in terms on porting Android automotive framework to a platform? Would it be possible to do without BSP, or is it too heavy task in terms of code? Okay, if you don't have a BSP, you're a bit on your own here. It's a significant amount of work to actually port Android to a new platform, and usually what you want to do is start from a BSP that's given to you from a vendor for a reference board or reference design, and go from that. So not impossible if you really want to do it on your own, but it's not, and we've helped people do that in the past. I mean, it's totally doable, but it's just not something that you usually want to do. You want to start with a BSP that the vendor's given you with functional HILs and HIDLs, so that you can then customize it to your own task. Other features like knowing the air pressure, oil level. So off of the private chat here, I'm being asked, does it support other features like knowing the air pressure, oil level, and so on? Yes, that's part of the actual vehicle property HAL. Those sorts of data that you may be able to retrieve from your vehicle would be in that HAL if you want to take a look at that. Who starts the car service? Is it a parallel to system server? Yes, it is parallel to system server. It is actually automatically started because the application is marked as persistent. So if I go back here under packages, services, a car, and then I go under service, if you look at the manifest file here, the application is marked as persistent. So that will cause effectively this app to be started straight away at boot up. And usually that will be through the activity manager, and then the activity manager will keep it alive all the time. If I kill it off, it will come back. So if I go out here and let me do just to show you as a demo, if I do a PS and I go looking for, again, the car, if I do a kill on COM Android car, which is this here, let's do a kill on 1973, do a PS again. So 1973 is gone, but you can see here the car service is back up as PID 4372. So when you mark an app as persistent like that and build it inside the AOSP, that's what you get as a behavior. I mean, just automotive framework in a platform with a standard BSP. Oh, sorry. Okay, I misunderstood your question. So if you mean just the Android framework, or kind of like getting the car stuff to run on some BSP that you have, that's not too bad. Okay, that's actually feasible. So in this case, it's just a matter of creating a new build target in your build system that actually does the car product on the BSP that you've got, whatever processor that you're running there, and so on. So there's a bit of legwork there of just a build system integration and flags and stuff like that. That's totally doable. All right, last chance at questions here. So there is usually between the time I talk and the time that actually goes out to YouTube a 10-30 second delay. So I'm just going to wait a minute here, see if we get more. Will you make your slides available? Yes, absolutely. Once this is over, either later today or tomorrow, I will post the link to the slides as part of the YouTube video description. So you'll be able to click there and get the slides. Yep. All right. Will this video be available at a later point of time to refer to? Yes, it will. I mean, once the live stream is over, it effectively becomes available as a replayable video on YouTube. So whatever link you use to join the live stream right now, you can reuse that to look back at this presentation. And in fact, for those of you looking at this later on, if you spot any errors in the presentation or anything that you'd like to add, please by all means just post it in the comments and we'll take it from there. All right. So thank you all for attending. Hopefully, we've answered some questions. And usually you pick up these topics based on what we see people kind of like asking questions about, or what the conversations we have with customers. So sometimes we see some conversations are recurring, and we keep talking about the same thing with customers. And usually I'll put some material together and share it with everyone to help people in their work with Android. So again, thank you all for attending, and hope to see you soon in another YouTube live stream. Thank you, folks. Take care. Bye.